Hello and welcome to Andy and Ian Talk Networking. I am Andy.
And I am Trey, not Ian.
Yep, so as before, we've got a guest speaker this week because Ian is sitting on an airplane. I think he's heading off to Down Under. So yeah, I've got Ian out. So Trey, welcome. And first time on Andy and Trey Talk Networking.
It's an honor to be here.
Yeah, so Trey, you've seen the format. You've probably watched us multiple times on YouTube. So really, we like to talk about different topics, dig into a little bit of depth, and kind of get a different perspective of the world. So today, I kind of going to pick on your brains a little bit because you are. I should probably recap to everybody. You are the cloud and AI product manager for cPacket. So I think this is a really good opportunity for us to talk about cloud in general and really about how we can do network observability in both a cloud environment and more of a hybrid environment as people start pushing and moving content and their services into a more clouded environment. How do we manage and do all that network observability?
Yeah, exactly. And folks are certainly on different paths in their journey in terms of getting cloud stood up in their environments. Some companies are cloud first. A lot of our companies or a lot of our customers rather are probably more of a hybrid scenario. But yeah, everyone finds themselves at a different point in their cloud journey. So probably a great set of topics for today.
Yeah, so when you look at kind of the way people are distributing their content, traditionally in the past, it was always, I've got to spin up my own server, I've got to deploy my email, my firewalls and all these other kind of, application servers. I have to run them in-house. Obviously, with the availability of cloud services that are now available, it's so much easier to start hosting that out there. And, initially we saw everybody pushing all of their services onto the cloud, and then we had a whole range of cloud services that went offline, so people started hauling it all back again. So really now you've got this kind of split, which we obviously call hybrid, where you've got some services in the cloud and some services locally. But that introduces a whole lot of management and fault finding problems for a lot of our net admins that we've got out there. So how do people solve that network observability problem when they're in that cloud or that hybrid environment? Because it's not like you can just turn up at AWS's data center and say, look, I want to just put this box into my part of my cloud network. They're going to send you away with a flea in your ear. But so really, I mean, just at a high level, how do we start by just putting the right components, or what components do we need to deploy to be able to monitor that network?
Yeah, for sure. So, depending on what vendor, everyone has their own architecture topology, but we have basically these observability nodes, which are dedicated Ubuntu boxes running in Azure, AWS, GCP, name your cloud environment. But really, we usually kind of start our narrative with it's all about getting access to packets in the cloud.
Okay.
And there's a couple of ways to start, how do you think about obtaining access to packets in the cloud? You can either rely on the native CSP tooling, such as AWS VPC traffic mirroring, or
Okay.
what was recently announced as public preview is Azure's VTAP virtual tap. So that's one option. And then we actually have our own agentless solution, which is kind of able to plug and play and really kind of act as more or less a router in the cloud that helps with packet replication and things like that to get
So that would be the
to enable.
traditional where we would use a packet broker or a network aggregator or something in the network in a physical environment. There are software equivalents that somebody can deploy on an EC2 or whatever the virtual machine environment they have.
Exactly. Yeah, exactly. And what we do is, we actually run the exact same packet capture software in the data center as we do in the cloud.
Okay.
So there's a lot of advantages for people that are hybrid, and it's the same tooling, the same interface, the same kind of deployment methodologies. All that's pretty consistent across the different the different mediums there.
Okay. And so they can deploy these. So presumably though, then they need to get the data. So they can deploy their brokers to actually capture, and they presumably can do filtering, or they can set up kind of these nodes in there. And I'm assuming they can deploy that through what their marketplace is.
Yeah, absolutely. So we are supported today in Azure and AWS marketplaces. We have all three of our products up there, and we're working on getting Google Cloud Marketplace support later this year.
Okay.
And yeah, it's all about modularity and what customers are looking for. A lot of our customers trend towards security delivery
Sure.
and kind of security enablement use cases.
Mhm.
And then we have another section of customers who are more interested in actual captured packets and then analytics on top of those packets that we are able to capture. So
Okay.
really just depending on what people are looking for, the use case.
Yeah.
But really security delivery and packet capture are really the two vectors there that we typically see with our deployments.
And presumably the packet capture, it's not like, in a data center you'd have a box just full of hard drives. So presumably there's a different architecture when you're in a cloud where you have this kind of virtual machine that is, doing the kind of the software processing and the analytics at the what we would call C-store level. Presumably though, it's then shoveling all that data out to some bucket somewhere that to be stored.
Yeah, so today we use EBS volumes or just disk volumes in Azure.
Okay.
For the storage of packets, we're working on actually supporting S3 later this year in terms of being able to actually write all of those packets to a common cloud storage bucket, which can be used, for reference, indexing, and you can almost think about it like a bit of a data lake per se, in terms of all your packet captures go into a single repository.
Obviously in the future, I don't want to go into it huge detail, but in the future, we'll be able to give that data lake access to machine learning models and things like that, so that we can then, build applications that can trawl through that data in the long run.
Exactly. Yeah, I don't want to go too far down the AI
No,
rabbit hole because we will get stuck on that. But
spoilers.
yeah, certainly a lot of cool stuff going on with what we're able to do with those captured packets, and how you analyze them, and the different technologies that are becoming more and more available every day to enable some pretty interesting things there.
Yeah, and presumably though there's a difference in scale, because when you're talking about in your data center, you may be running, tens or hundreds of gigabits worth of network traffic, or even 400 up to 800 in the future. But presumably you don't have that level of data, quantity of data when you're in a clouded hosted environment. So how do the packet brokers scale different to maybe when you're in a on-prem?
Yeah, it really is quite different. And, we've learned a lot working through our cloud portfolio for the last few years. But typically, you can think about our VMs generally supporting, it's depending on the CSP provider, but for simplicity's sake, generally each observability node or each packet broker node can support 10 gigabits a second in terms of throughput. And then we support the native Azure virtual machine scale sets or AWS auto scaling groups. And so we're able to basically dynamically scale based on a variable amount of traffic, in terms of gigabits per second. So typically we'll deploy 2 to 3 packet brokers just for high availability and resiliency to start with. But as traffic either scales up or down, we can dynamically spin up or spin down new instances to support the variable traffic workload. And we have a load balancer. Yeah, so load balancer fronting, a backend pool of instances essentially. So that's how we're able to handle scaling or auto scaling in the cloud. And yeah, it really is quite different, obviously, in comparison to a data center where you're having to physically wire in a new box and put it on a rack and all of those types of things. So quite a different philosophy. But yeah, I mean, it's the CSP providers have actually done a pretty good job of making it pretty seamless to dynamically scale. And there's a lot of configurability and modularity there in terms of how you might think about inserting that.
Great. And what about managing though? So, one of the things is you've now got all these nodes of, these virtual packet brokers and these virtual storage that are decimated, could be anywhere in the world in any instance. How do you bring all that management back, but also, be able to not have to have different tools for cloud versus, your data center? Is there how do you manage that kind of aggregation of that two different data sets?
Yeah, it's a great question. So we have a product called our cClearV Control Center, which is available in a physical format, and then it's also available in our cloud environments. So the cool thing about cClear is it's totally agnostic to where you're running your workloads. So you could have a cClear node up in AWS, which is managing your AWS workloads as well as your physical workloads, or vice versa. You could have a cClear in a data center, managing both of those vectors. So yeah, our approach to manageability is we want to enable that management wherever customers feel comfortable running that. And so it's really just depending on the preferences, and if people prefer a rack in a data center, then we have that option. Or if they prefer just spinning up some software in a number of minutes on the marketplace, it's very simple to go out and stand one of those management instances up.
Right. Yeah. Okay, no, that's great. Appreciate the insights there. It was yeah, good discussion. I'm sure there's a lot more that we can talk about, but we're out of time. So I just want to say thanks, Trey, for joining us. Appreciate your time and effort. And I'm sure we'll have you on again to talk about other things, maybe AI
AI.
related,
Yeah,
maybe a little bit
maybe
of
AI
AI
next.
stuff in you know, maybe in sometime in July after we've got an upcoming security field day in about a week's time, and then we've got a network field day coming up in July. So that might actually be a good opportunity for us to bring you back and talk about AI for network observability. So I appreciate your time today, and yeah, just want to thank everybody for watching. Again, please remind you to like and subscribe down below. It really helps us, and you know, it gives us good information about exactly what you guys find interesting, what you skip through. You know, you go through my dulcet tones. So, but yeah, really appreciate if you could do that. And again, just like to thank everybody. So I have been Andy.
And I am Trey, and it's been
Thanks,
a pleasure to
everybody.
be on today.